Hello everyone! Today we'll learn control flow in Python. Control flow is simply how Python decides what to do next. Sometimes we want the program to make a decision, like, is it hot? Is it cold? Sometimes we want it to repeat a task, like checking a sensor reading again and again. By the end of this session, you'll be able to write code that decides and repeats in a clean way. Let's start with conditional statements. A conditional statement lets Python choose between different actions depending on a condition. The main keywords are if, check the first condition, elif, check another condition if the first one is false, else, run this if none of the above conditions are true, and the condition must be something that becomes true or false. We call that a Boolean expression. If temperature is greater than 30, that's true, so we do the hot message. Now we see a full example. First, the program asks the user to enter the temperature as an integer. Then it checks conditions in order. If temperature is above 30 leads to print hot day and also drink water, else if above 20 leads to print nice day, else if above 10 leads to print a bit cold, else leads to print cold. Finally, it prints done. Important idea, only one branch runs in an if-elif-else chain. Python stops at the first true condition. Here we connect this to Mechatronics. Imagine a temperature control system. The code reads a temperature value. Then it decides above 30, then cooling on, above 20, then normal operation, above 10, then heating on, otherwise then extreme conditions. This is exactly how many control systems begin. Read sensor leads to decide mode, leads to output action. If you had a real system, what could cooling on mean? Fan, pump, compressor? Please pause the video, think, and answer. This one is more realistic for protecting equipment. We read component temperature and classify it. Above 100 leads to overheating, shut down immediately. Above 70 leads to high temperature, reduce load. Above 40 leads to normal operating range. Else leads to temperature too low, increase load. Notice, the messages are actions, not only descriptions. That's the goal in engineering, detect state and respond. Thresholds, 100, 70, 40, are design choices. In real projects, they come from datasheets, experiments, and safety rules. Same logic, different context, grading. We input a mark, then classify it. 90 plus is A, 80 plus is B, 70 plus is C, 60 plus is D, else F. This example is good because it shows correct ordering. We must check the highest boundary first. If we start from 60 first, everything above 60 would become D, and we lose A, B, C. Now we move to loops. A while loop repeats code as long as a condition is true. So it's like, keep going until something happens. We can also put if-elif-else inside the loop. That means every time we repeat, we can make decisions again. Perfect for sensor monitoring. To conclude, while loop, r, repeat. If statement, bar, decide. This is a monitoring loop for pressure. We start with pressure = 0. While pressure is less than 100, we keep asking the user to enter pressure again. Inside the loop, if pressure 80 leads to warning high pressure, else if 50 leads to normal operational pressure, else leads to low pressure, check system. So the loop continues until the pressure reaches 100 or more. That's like a real system. Keep reading pressure until it reaches a safe target. Important warning here, please be advised that, in real life you must always think about, what if the loop never ends? That's called an infinite loop. You prevent it by updating variables correctly, adding timeouts, or adding stop conditions. Now we learn the for loop. A for loop iterates over a sequence, a list, a string, a range of numbers. Strings in Python are sequences of characters, so we can loop through each character and do things like counting, checking, or filtering. 2 as a comparison, for loop is best when you know the items you want to go through, while loop is best when you repeat until a condition becomes false. Here we count how many times the letter I appears in the word Mississippi. We set count hours 0. Then we loop over each character in the string. If the character is not I, we use continue. That means skip the rest and go to the next character. Otherwise, we increase count by 1. At the end, it prints the total, which is 4. This is a powerful pattern. Loop plus condition plus counter. Again here, please think of the following question. Pause and answer. What happens if we remove the continue and rewrite the logic differently? This is a more engineering-like example, analyzing equipment codes. We have a list. MTR123, VVL456, PMP789, VVL101. We want to count how many are valves. Here, VVL indicates a valve. We loop through each code. If VVL is inside the code, we increase VVL count. Then we print each code with a label, valve or other. Finally, we print the total valves. Two key skills here: searching inside strings using in, working with lists and counters. In a real factory, you might process thousands of tags like this and generate a summary report. Nested loops means a loop inside another loop. Why do we need this? Because some data is naturally 2D. Images, rows and columns, matrices, grids, tables. The outer loop usually controls rows, and the inner loop controls columns. Think of it like a spreadsheet. You go row by row, and inside each row you go column by column. This example prints a triangle of stars. Rows, stars 5 outer loop. I goes from 1 to 5, that's the row number inner loop. J goes from 1 to I. Number of stars increases each row, then print a new line after finishing each row. So row 1 prints 1 star, row 2 prints 2 stars, until row 5 prints 5 stars. This looks simple, but it teaches you how nested loops build patterns. If rows the number 10, what changes? Only the height, or also the logic? Now we do a grid pattern with X and O. Size, Drucker 5 means a 5 by 5 grid. Outer loop is rows, I. Inner loop is columns, J. We print X on two diagonals. Main diagonal, I, Jobber J. Other diagonal, I plus J, short chuck size. 1 everywhere else we print O. This is a classic matrix logic problem, and it appears a lot in robotics, computer vision, and grid-based maps. Final question I have for you here. What would happen if size was 6? Would the diagonals still work? Yes. Same logic, bigger grid.